Okay, we are going to talk about slope, y-intercept, and r squared. At least we'll introduce r squared and do a little bit more of that in the other videos. But slope, here we have an equation. The price of a home in dollars equals $45,000 plus $170 times every additional square foot, every square foot of the house. So your job is to identify the slope and the y-intercept, what it represents in context for the home. So I would like you to pause the video. I would like to write what you think this tells you about the slope in words and the y-intercept in words. So again, this is a video, so I'm going to assume you have paused the video, and then we're going to look at it, and now we will talk about it. Now, it might be easiest to think of it like you would graph this. And if you were to graph it, you would graph the y-intercept first, which would be $45,000. So 45,000, let's just say, we're on here. This is 20,000. These are in thousands. This is 40,000. You would go up to 45,000 and you'd put a dot. Well, what does that mean? So the y-intercept in words would be this. If the square feet of the home is 0, we'd put a 0 in there. That would cross this off. We would expect the price of the home to be $45,000. So in words, the y-intercept, which is 45,000, if the number of square feet is 0, if I put in a 0, that's what the y-intercept always is. The y-intercept, if I put in a 0, it is predicted the home will cost $45,000. So, if you are asked to explain the y-intercept in words, what you always do is you put in a 0, but you talk about it in context. If the square feet were 0, the price of the home would be $45,000. Now you might say, does that even make sense? Well, if this home, if it wasn't here, what you would still have is you would still have the land, and that land could be worth $45,000. So it actually does make sense. If there wasn't any house built there, the property is still worth something because the price of the land the home is on is generally included in the price. So that does actually make some sense. Okay, now what does the slope say? Now the slope is the 170. So now think about if you were graphing this. We would go up $170. Now in the context of these being $40,000, $45,000, it's not going to go up too much. But we'd go up $170 and then over 1. We'd end up with this positive sloping line, and it would continue to go up 170 over 1. Now that's not drawn very well, but what we would have is the price of the home. Now, one of the things you want to talk about these in y over x. Remember, this equation, y is here. So that $170 belongs with the y. The price of the home is expected to rise $170 for every one more square foot that you add to the home's size. Every time we add a square foot, we expect the price to go up 170. Now, a couple things I want to point out. In both of these, I talked about this being predicted. So you want to always say, it is predicted, or we predict, or I predict. It can be we predict as a class, I predict as a student, but it is predicted. The whole idea of the equations when we write these equations are predictions, they're not guarantees. So remember, they're built on a best fit line. And that best fit line, it may not hit any of the points. It might miss all the points. And then I happen to hit about 3 of the points, but just by mouse drawing. Anyway, but it may not, it's a prediction what will happen. So remember, the square foot, if the square feet is 0, we predict the home is 45,000. You're putting in a 0 to do the y-intercept. And then always remember, when you talk about the other one, it's y over x, and it'll generally always be a unit of 1 increase on x as you go across. You'll go up or down with the y and then over on the other one. So now I'd like you to pause. Oh, here's in general what you need to memorize. The slope. It is predicted that y in context. So like for example, the price, right? Rises, falls, goes up, goes down. You're going to have something like that. So in this case, it was rises $170 for every one more unit in x. And what was x? One more square foot. Okay, now I'm just using that as an example. Those blanks are going to change from problem to problem. This number, 170, is going to change from problem to problem. X will go up 1 unit every problem. All right, now the y-intercept, if x is 0, whatever the context. In our case, it was the square feet. If the square feet were, oops, that's supposed to be a q, square feet is 0, it is predicted that y in context, well, what is y? The price is, and then it's going to have some value that you would get when you put it in there. And that is, it always happens to be your A value. That is your y-intercept. So those are the things that you want to get down and memorize and understand that's what we're doing. So I'd like you to pause the video. I'd like you to try this next one. We have an equation. The total cost, again in dollars. Assume that we're going in standard American units, whether it be dollars or feet or pounds or whatever it might be. So go ahead and do this one. Little diet do. And here we go. So I'm going to start with the slope this time. So the slope, remember, that's this one. Remember, it's y. So it's always y over x. It always kind of goes left to right, so to speak. So it's predicted the cost increases by 25 cents for every additional mile driven. That common kind of theme with car rentals, that you pay so much per mile, probably more than a quarter a mile. It's probably an old example. Y-intercept, if you drive 0 miles. Now it's always, if you put this in as 0, well, what's going to happen? 0 times anything 0? Oh, then the cost is predicted to be $35. I guess if you rent the thing and you don't drive anywhere, I don't know why you rented the car, then that's what you would pay. But that's the initial cost of the car rental. Okay, so everyone, can you try example 3 with the phone bill? Again, pause the video. I'm going to go on in about 5 seconds here. So here we go. The slope, we predict the monthly phone bill increases by 10 cents for every 1 more minute used. Boy, that's an old type problem. Wow. Never mind, I'll just ignore it. That's like back when I was in college type problem, paying 10 cents a minute. Now it's like you just pay for your cell phone. They still are getting you for the amount you call. It's just they just charge us a whole bunch anyway. All right, y-intercept. If the number of minutes used is 0, it's predicted the bill will be $40. Got to pay to have the phone. Okay, try example 4. Try example 5. Try example 6. I'm going to let you pause the video, try all 3 of those, and then we'll go through the solutions. Okay, we'll go through the solutions. Now remember, on all these, are you putting the words "it is predicted"? That's what this hat means. It's not a guarantee. So some students, you might have it in the My Math Lab, the Pearson Math Lab homework, that it doesn't put the words "it is predicted." On the AP test, And on my test, make sure you put it is predicted. It is predicted the fare increases by $2.50 for every additional mile. Remember, the X increases by 1, so the mile goes up 1. The y-intercept, if the number of miles were 0, it is predicted the fare will be $5. I don't know why you got in the taxi cab to begin with. All right, I'm going to assume you have paused it. If you need more time, pause. Here goes example 5. Gym membership. It is predicted the total cost increases by $15 for every additional month of membership. Y-intercept, if the number of months is 0, it is predicted that the total cost, I can't get this thing to move, will be $50, which is basically the sign-up fee, right? Okay. Number 6, ice cream. It is predicted the sales increase by $12 for every additional degree in Fahrenheit. If the temperature is 0 degrees, it is predicted sales will be $200. I talked about ice cream in class the other day with my students at Washington. And I said if it was 90 degrees out, you'd have high ice cream sales. Everybody's like, yeah. And I said if it's 30 degrees out, then I had a bunch of people that said, I still want ice cream. Fair. Okay. So apparently $200 in sales and ice cream still happening. Oh, what did the cow say to the calf when he stayed up too late? It's past your bedtime. Sorry, I have to have some of my silly humor worked in. Couldn't take that one out. Anyway, now that you're kind of rolling over and groaning from that, let's keep going. R and R squared. R is the correlation coefficient. Remember, R, this is just review, R is between -1 and 1. R tells you how strong it is. So remember, there's some standards. 0.75, if it's bigger than 0.75, it's strong. If it's in between 0.75 and 0.30, it's moderate. If it's less than 0.30, it's weak. And that includes things like -0.96, that'd be really strong. So it's the absolute value of R, you know, in terms of the strength. The -1, +1, those are perfect. But now, today we're going to talk about R squared. Now, R squared is R, whatever R is. If R is 0.9, you square it, it's 0.81. If R was -0.9, you'd square it, and it would be positive 0.81. So R squared tells us the percent of the variation in Y explained by the variation in X. X is the explanatory variable. X does the explaining. It doesn't necessarily cause Y, so be careful with that. So R squared tells us a fraction or a percent. It's the percent of the variation in Y that is explained by X. And on this one, can you wait a couple minutes? Because I am doing a video right now, and I'll be done in about 6 minutes. Okay. So, now, here we go. Let's find this. Pizza toppings. So we have this formula for pizza toppings. And where did my Inspire go? I had it up, and now it went away. Okay, somehow it closed it on me. Okay, so I'd like you to plug those values in for the prices of the pizza toppings. Okay, let's plug them in. If you're using the Inspire, we would probably call these like X and Y, and we'd have 0, 1, 2, 3, 4, 5. And you're substituting those in. And if I put in 0 into that equation, I should get $7, because 0 times that. Now that would be the y-intercept. Now we're making this data But then we put in the next one. We're making this data from an equation. We're going to talk about that. Then we put in $8.50. Then we put in $10, then $11.50 if you're substituting those in, then $13, and then should be $14.50 if I did all those right. Let's see. Okay, so if you're doing the Inspire, on the Inspire, we go ahead and add a data and statistics page. We'll make a graph of X and Y. Now I'm actually going to do this one on both, but we have the X and the Y. If you go to a calculator, we're going to go menu 6, number 1. We're going to do linear regression number 4, and we're going to do X and Y. We're going to click OK. We get this equation. Y equals 7 plus 1.5 times X. Surprise, surprise, it gives us this exact value, and it gives us R and R squared, and R squared happens to be 1. Okay? Now, let's take this and let's do Desmos. And if you're not familiar with Desmos, they are allowing Desmos on the AP exam. You would click plus, you would do a table. You can call these, you can leave them X1, Y1, doesn't matter. I'm going to put in the same values, 0, 1, 2, 3, 4, 5. Then I'm going to put in the values that we got from the equation. We had 7, 850, 10, 1150, 13, and 1450. Okay. Now, if you have this little green thing on, this little green thing will graph it, but we don't see it. So whenever you use Desmos, there's a zoom fit over here, and we hit zoom, and there we have our equation. Now up here, there's a little add regression. If you click that, it'll add the regression line, and we get all the same things. We get y equals 1.5x plus 7. It builds the equation. It's right on the screen. What I like about Desmos is some of the things are right there right away. We have the r and the r squared value. R squared is 1. If you want to click plot the residuals, you can plot the residuals. The residuals are all down here. If you're plotting the residuals on this one, you have to go menu 4, 7, no, 4, 6. You have to go 4, 6, 2, show the linear regression, and then menu 4, 7, 2, you have to add the residual plot, and none of the residuals are away from the line. So whether you're using Desmos or you're using the Inspire, you get the same thing. You get that r squared is 1. Now we want to define r squared. So how do we define r squared? Okay, r squared is the fraction or percent of the variation in y explained by x. So this is the correct statement. I'm going to show you the correct statement. This is it. 100% of the variation in y, which is price, is explained by the number of toppings, x. A wrong statement is this: 100% of the price is caused by toppings. Don't ever say caused. We'll talk about what do I memorize with r squared, and we'll work on this more in the other videos. Okay? It's the variation in y. If we're looking at this line, none of the points deviate or vary from the line. If they were above and below the line, they'd be varying above and below the line. We'd have a different value for r squared. They're all hitting the line, so that's why it's 100%. When you do other equations, you're going to find you might have an r squared that's pretty high, but it's varying above and below the line, and r squared could be, example, like 82.4% or something. Well, 82.4% of the variation in y, the up and down movement, is explained by the x variable. The x is that variable. Okay, so it's something you have to memorize. This will be the last part of the video that I put on here. But you have to memorize this statement for r squared. And I'll talk about it more in the other videos. This is kind of an intro. R squared percent of the variation in Y, whatever the context is, in our case it was price, is explained by the number of toppings. Okay, so that's what you have to memorize for R squared. It'll be on the test. It's usually worth 2 points on my next test. And we'll stop there for today. Thanks for watching.